Hey everybody, Mr. Troy here. Sit down, get comfortable, grab a pen, maybe crack an ice cold LaCroix, because it's time for math with Mr. Troy. Alright, so the focus of this video is factoring by grouping, which is a way that you can factor things that have 4 terms. You might have seen this before, you may not have, but it's a useful and interesting way to do things. So let's start out. You're only going to use this on things that have an even number of terms, or that things that you can figure out how to write with an even number of terms. So, for example, I would look at the first 2 terms and I would factor out their greatest common factor. So in that case, that would be 2x. I would be left with x plus 2. And I'm going to factor so that I get the same thing in the second set of parentheses here. So I could factor out a positive 5, and that would also give me x plus 2. If that is something you can accomplish, then your next step is to write that as 2x plus 5 times x plus 2. And you're done, and it's factored. So the 2x plus 5 came from here, and the x plus 2 came from here. So what you're actually doing when you do that is you're saying there is a common factor here. So I can pull that out, and when I pull that out, I'm left with 2x plus 5. Now we don't write it that way, we write it this way. All right, so pause the video, see if you can do the next one on your own. Did you pause the video? Pause the video, see if you can do the next one on your own. All right, here goes. So sometimes you will notice a pattern. So for example, the 3 and the 3, and the 5 and the 5. Or in the problem below, 1a, 2a, 5b, 10b. So let's just do this example. The greatest common factor from the first 2 terms is 3x cubed. And that's going to leave me with x squared plus 1. If I factor out a 5, I'm also going to be left with x squared plus 1, which means that overall, this expression factors to 3x cubed plus 5 times x squared plus 1. Now, this can get pretty challenging. So the greatest common factor from this last one, for the first 2 terms only, is ax squared. So that's going to leave us with x plus 2. And from here, we can factor out a 5b, and similarly get x plus 2. Our end result will be ax squared plus 5b times x plus 2. So here's an example of a problem that is not set up to work that way, but that you can set it up to work that way. This is where it takes a little bit of thought. So if you look at 5x and you can split it up into something where there's a common factor in both directions. So here's what I mean by that. if you can do plus 9x minus 4x minus 6, then suddenly there's a common factor between the first two terms and the second two terms. It takes a bit of guess and check because you have to make sure that that pattern still exists. What do I mean by that pattern? Well, if I factor out a 3x, I'm left with 2x plus 3. And then if I factor out a negative 2, I'm left with 2x plus 3. So that pattern that I'm talking about is, can you pull the same thing out of both the front half and the back half? And just like all factoring, that takes practice. Not everyone does it that way because it's not the first thing that pops into people's brains. So overall, this would factor to 3x minus 2 times 2x plus 3. And later on, I will present you with a different way to factor that exact same thing. All right, everybody. Thanks for watching. Make sure you keep trying hard. Okay, do all of your work. It's a tough time for everybody, so hang in there. I've been Mr. Troy, and this has been Math with Mr. Troy.